We're getting ready to start Chapter 8, which is exponents, negative exponents, operations with exponents. So we're going to start with a little bit of a review where you have seen exponents used with numbers called scientific notation. And we'll review exactly what scientific notation is first. So you have a piece of paper ready. We're going to do some examples together. From the four numbers I have listed below, take a second and decide which ones would be scientific notations and which ones would not be. Okay, so if we look at the first one, this one is not scientific notation. The reason why, the first number, the whole number, or not, I'm sorry, it's not a whole number, the number without the exponent has to be a number greater than 1 or equal to, but less than 10. And 23.1 is not less than 10. Too big. If it said 2.31, then we'd be okay. Okay, second one. Yes. The first number is a number that's less than 10, but greater than or equal to 1, so between 1 and 10. And the second part of the number has to be a 10, and it has to be to some power. So this is a yes. Third one. First number is between 1 and 10. It's multiplied by 10 to some power, so it's a yes. Last one. Two things wrong with this. First of all, that's too big. It has to be less than 10. Can't be 10.0, can't be 10 point anything, so it's not scientific notation because of that. Also, this number has to be a 10. So it has to be 10 to some power. So number between 1 and 10 multiplied by 10 to some power. I'll just put a little X up there. Multiplied by 10 to some power. Alright, so next thing we're going to do is we're going to actually practice writing them. So I've got three numbers listed. All three of them are in standard form, which means just written out like we normally see numbers. If I need to write them in scientific notation, what you're basically going to have to do is move the decimal point. 23,000 is too big. We just said that the first number has to be between 1 and 10. So to make 23,000 a number between 1 and 10, I have to move that decimal point that right now is at the end of the number. I have to move it over until it's a number between 1 and 10, which would be 2.3. How many times did I move it? Well, I moved it 1, 2, 3, 4 times. So that's our number in scientific notation. If I multiply 2.3 times 10 to the 4th, which is really 10,000, I'll be back to 23,000. Okay, let's do the next one. So same idea, 34 million turns into 3.4. And the decimal point was originally at the end of 34 million. We had to move it, looks like 7 places. So that 7 becomes my exponent. Next one, 0.00045. We're still aiming for a number between 1 and 10. Well, that's way too small this time. So we're going to move the decimal point to make it 4.5, which is between 1 and 10. And we had to move it 3 times. But the difference here is, I'm sorry, we have to move it 4 times. 1, 2, 3, 4. Difference here is instead of 10 to the 4th, we're going to do 10 to the negative 4th. Here's how I remember this. If I have a large number, like these two, large numbers are going to have positive exponents, And if it's a small number, in other words, 0 point something, so less than 1, if it's a small number, it's going to have a negative exponent. And that's actually going to be our next lesson, is negative exponents. We'll do that in class, hopefully. And you'll see why small or negative exponents actually make very small numbers. They don't make negative numbers. That's not a negative number. There's the bell, but we're not done. They don't make them negative numbers, just very small numbers. So this is all review. You should have done this last year, but hopefully we'll be good at it. And we're going to look at the other way around now. So now let's go backwards. So what we just talked about with negative exponents, we should end up with a small number. So this -5 right here tells me I should move the decimal point 5 places, but I want to make it a small number, not a larger number. So that 6.8, we're going to move the decimal point back this way 5 places. While the 6 takes up one of the places, the other 4 places are going to become zeros. So 1, 2, 3, 4, 5. There's our number. Now you can also write this as 0.000068. And that's the same thing. Not picky. The same number. Okay, second one, 1.0 times 10 to the 8th. It's a positive exponent. We should get a large number. So go ahead and write what you think that would be. I'm getting 100 million. The 8 exponent moves the decimal point 8 places. In this case, we ended up with 8 zeros, but that is not always the case. Let's do another example with the positive exponent. Let's do 3.56 times 10 to the 5th. Well, in this case, when I move the decimal point 5 places, 2 of the places are taken up by the 5 and the 6. So we only need to add 3 zeros to make the 5 places. So this would actually be 356,000. So that's 356,000. So just keep that in mind. Don't just count zeros. All right, last one. 8.8 times 10 to the -2. So you want to move the decimal point 2 places to make it a very small number. Eight takes up the first place, add one more zero for the second place. And again, 0.088 would be the same thing. All right, last thing we're going to look at is multiplying. If I have a whole number and I'm going to multiply it with a number that's in scientific notation. So example looks like this. 8 times 2 times 10 to the 3rd. Okay, so we've got the whole number 8. We're going to multiply it by 2 times 10 to the 3rd. Now most of you, I shouldn't say that, some of you may want to make that 2 times 10 to the 3rd into standard form, then multiply by 8, and then put it back in a scientific notation, but there's a much easier way. Go ahead and multiply 8 times 2. And then this part, so as long as I multiply the 8 times the whole number, I'm multiplying it by this whole entire number. It's not a distributive property. Those aren't two separate things. 2 times 10 to the 3rd is one big number. So when I multiply by 8, I get 16 times 10 to the 3rd. Now, the only problem is this is not scientific notation. Check out this number right there. It's too big. If I want to make a scientific notation, I would have to change that 16 into a 1.6. Well, I just moved the decimal place one place over, so we're going to have to somehow incorporate that into our exponent. Since that was 16 times 10 to the 3rd, this would turn into that. It's going to become 16 times 1, 2, 3, 4, 10 to the 4th. We moved it one place over, we changed the exponent by 1. But here's an easier way to do it, because I don't like to do all this stuff. If I had to make this number smaller one place, then I'm going to make the exponent bigger by 1. Watch this again. Let's pretend like I have 35 times 10 to the 4th. That would turn into 3.5. I just made that smaller. So I'm going to make the exponent 1 bigger. Same number. If I have to take one like 761 times 10 to the 4th, I'm going to have to move the decimal place 2 places, decimal point 2 places, smaller. So I'm going to make the exponent 2 bigger. Kind of balances it out. If you make the whole number smaller, make the exponent bigger. All right, I think you're ready to move on and try some of the worksheet. It's attached.